Hello, my name is Dan Sutton, and I'm excited to introduce you to my invention. This is an electronic tattoo machine pulse generator that I have named Panic Switch. It is, to my knowledge, the first of its kind. Panic Switch overrides the traditional tattoo machine's mechanical electrical switching mechanism and takes full electronic adjustable control of oscillating the needles, enabling a tattoo artist the ability to fine-tune and adjust the speed, performance, and efficiency of their tattoo machine electronically. Since the modern two-coil tattoo machine's invention in 1899, not much has changed with the underpinning mechanics of its operation in an attempt to achieve a better, more efficient operating machine. Now before I get started, I want to quickly explain to those of you who do not understand how a tattoo machine works. This is a tattoo machine. It has two electromagnetic coils that, when energized, magnetically draw this armature bar downward, which forces the ink-laden needles to puncture the skin. The electromagnetic coils get positive voltage directly from the power source, and the power source's ground floats throughout the metal chassis of the tattoo machine. The ground wires coming out of the electromagnetic coils come up this binding post and terminate right here at this contact screw, where it touches the front spring of the armature bar, which delivers ground to the electromagnetic coils and allows them to become energized, which pulls the armature bar downward. However, when the armature bar gets pulled downward, the contact is lost between the ground wires coming out of the electromagnetic coils and the ground of the chassis. So the electromagnetic coils become unenergized and are no longer magnetic, and so the spring on the back of the armature bar pulls the armature bar back up to resting position, where the armature bar, the front spring of the armature bar, makes contact again with the contact screw and allows the electromagnets become energized again, and the cycle repeats over and over and over and over again, about 80 to 120 times per second. Now before I move on with demonstrating Panic Switch to you, I want to explain two things to you. The first is the frequency, or the tattoo machine frequency. A tattoo machine frequency is measured in either Hertz or cycles per second, and I want to clarify that Hertz is just another way of saying cycles per second. Hertz is a measure of the number of up and down or on and off cycles that occur every second. If I were to say that my tattoo machine was running at 100 Hertz, would be the exact same thing as saying that my machine is running at 100 cycles per second, or that the needle is penetrating the skin 100 times per second, or that the electromagnetic coils are being switched on and off 100 times per second. I'm an electronics guy, so I'm more accustomed to thinking and talking about these cyclic, oscillating, changing periods as Hertz. The other thing I want to talk about is the duty cycle. The time that the electromagnetic coils stay energized versus unenergized throughout the armature bar's downward-upward cycle is called the duty cycle. And here, you can see on this graph here, on this table, you can see that with a 100% duty cycle, the electromagnetic coils in the tattoo machine would be turned on all of the time. They would never be turned off. To where with a 0% duty cycle, the electromagnetic coils would be turned off all of the time and never turned on. Here with an 80% duty cycle, you have the electromagnetic coils are being energized or turned on 80% of the time and off or unenergized 20% of the time. Where on the other hand, with a 20% duty cycle, you have the electromagnetic coils are only on for 20% of the time and are turned off for 80% of the time. Here, with a 50% duty cycle, the electromagnetic coils would be turned on for half of the time and off for half of the time. So that is duty cycle in a nutshell, and understanding frequency and duty cycle is sort of important to being able to understand how to use Panic Switch to fine-tune your tattoo machine. Okay, back to Panic Switch. So the only way for a tattoo artist to adjust the speed or performance of their tattoo machine is to either increase or decrease the voltage from the power supply, which also affects the downward force of the armature bar and needles. They can increase or decrease the depth of the contact screw, which will either allow the armature bar to travel up further or only allow it to travel up so far. Or they can change the spring tension on the front or the rear spring, which will effectively adjust the duty cycle of the electromagnetic coils. So all the adjustments that could be done to a tattoo machine are all done mechanically. With the panic switch, tattoo artist will now have the ability to electronically adjust their machine's speed, as well as independently adjust the duty cycle of their machine's electromagnetic coils without altering any of the physical mechanical properties of their tattoo machine. In other words, the tattoo artist can mechanically set the depth of their contact screw to their specific preference, adjust the voltage appropriately, not have to change the front or rear armature bar springs, and still have a huge spectrum of digital adjustment to control the performance of their machine. Before a panic switch will work on a tattoo machine, the power connector must be upgraded from the standard spring clip cord that's been around since the tattoo machine's early infancy to an RCA style cord connector such as this one here. And I'll show you here. It's just a standard female RCA jack. The reason is simple. The spring clip cord does not offer a good tight electrical connection, thus there is too much resistance in the connection. Panic switch requires a good, clean, tight electrical connection with very minimal resistance, therefore the RCA style cord is necessary. The RCA style cord has been gaining popularity in the tattoo industry over the years as a means to connect a tattoo machine to power with very minimal resistance. Conversion kits are readily available from tattoo supply companies or can easily and inexpensively be made out of parts from stores like Home Depot and Radio Shack, such as what I did with my machine. It's very easy to convert a tattoo machine's power connector to RCA, and it only took me a minute or two. Here I have my tattoo machine running as it normally does, using conventional mechanical switching operating method. Now I will hook up my machine to panic switch, but before I do, I have to run this bypass jumper wire from the chassis of the machine and up here to the top contact post. And what this does is bypasses the contact points. Now the electromagnetic coils will stay energized whenever power is applied to them, and the armature bar will remain down. Watch. Armature bar goes down. It stays down, does not return up until power is turned off. In order to make the armature bar travel up and down for tattooing, power must be turned on and off very fast, like about 80 to 120 times per second. That's where panic switch comes in. The panic switch can turn these electromagnetic coils on and off as fast as 160 times per second. To hook up panic switch, I make sure that the power supply and panic switch are both turned off. I then unplug the power cord from my tattoo machine and plug it in to panic switch. I then take my other cord and plug it into panic switch and have the other end of the cord plugged into my machine. Next I turn on the power to my power source. And I plug in panic switch. And a little graphic goes by, it says panic switch version 2.75 LS, which is one of 3 versions created by myself. My email, panicswitchtattoo@gmail.com. A little slogan I came up with: bring your tattoo machine into the 21st century. Then watch this. That demonstrates that panic switch has got full control over the switching on and off of these electromagnetic coils. And panic switch is ready to run. This particular model of panic switch, the LS, is capable of running a tattoo machine between 60 and 160 Hertz in 20 Hertz increments. The S model runs a tattoo machine between 50 and 100 Hertz in 10 Hertz increments, and the L model runs a tattoo machine between 110 and 160 Hertz in 10 Hertz increments. Now let's start out running my tattoo machine at 120 Hertz. Every tattoo machine is different and will run most efficiently at different duty cycles than another machine might run most efficiently at. Notice the change in the machine's running as I climb through the duty cycle percentages. There it starts to bite down. You can hear the machine is actually starting to respond. It's running better and better at each percentage that I climb through, until right about there at 41%. That's about where it's running best at with 120 hertz. And anytime I continue to push the button, the performance is probably going to start to decay. As you see right there, I hit 43%, and the performance began to decay. And there's 46, 47, it just continues to decay. It's like you hit that sweet spot where the performance doesn't get any better, and then any further adjustments causes a decay in the efficiency. To 140 hertz. Notice the difference in the performance of my tattoo machine as I increase through the percentages of the duty cycle. There's 38% duty cycle. The thing's humming along pretty good at 38%, but then as I continue to increase the duty cycles, it gets a little bit better until it's 41%, 42%, 43%, 44, 45, then it begins to decay as I continue to go down as I continue to increase through the duty cycle. Here's 47%, 48, 49 decrease. It decreases quite a bit at 49%. So I'm going to go ahead and say 46% duty cycle is what runs my tattoo machine the best. Now we're moving up to 160 hertz. This is a very fast frequency for a tattoo machine, and this is much faster than most tattoo artists would tattoo with. But the panic switch is capable of running at 160 hertz. I just thought I'd demonstrate for you that it is able to do such a thing. So here's 160 hertz. As I continue to toggle up through the duty cycles, it begins to run a little better. At 47%, it begins to run. 49%, it's running pretty good right there at 49%. 51, 53%, and then it begins to decay right instantly at 54%. You go from 53% to 54%, and it instantly just goes right downhill and crashes, and now it's not running anymore at all. Now I'm going to show you some of the lower frequencies that Panic Switch is capable of performing. This is 60 hertz. And notice that the lower the frequency of the Panic Switch, the lower the duty cycles are that it performs best at, and also gives you a broader range of duty cycles that it works with too. So here's, 60 hertz runs best at about 30%, 31%. Here I'll take it up to 80 hertz. There's 80 hertz. Runs best at about 31, 32, about right there's 40%, then it starts going downhill after 40%. That's 41%. That's 41% duty cycle, and it just begins to decay any further above 41%. But like I said earlier, every tattoo machine is going to run differently. This particular tattoo machine has kind of a weak rear spring. I think a tattoo machine with a stiffer rear spring would work better at higher duty cycle percentages than my machine does per se. And here's the last frequency I'm going to show you, which is 100 hertz. Notice that efficiency goes better and better as I go higher into the percentages of the duty cycle. Right about there's 39%, and about 41% it begins to decay and is no good again. I'm going to show you one more time here, 100 hertz. It's running pretty good there, 37%. And then at about 40% it begins to decay right there. And that's Panic Switch in a nutshell. I hope that I raised an eyebrow out of at least a few of you viewers of the video. I have a lot of time and energy spent into the development of Panic Switch. If you have any questions and would like to contact me with inquiries about the Panic Switch, please send your emails to panicswitchtattoo@gmail.com. That's PANICSWITCH tattoo@gmail.com. Thanks for watching.